Okay, just a quick introduction. Okay, so we have Sai Siva Koti Reddy. So this is the first class for you. Actually, we have covered the sequel session in the last 1 week, and yesterday we started a new topic. It's called business intelligence. It's the overall view how why we need why we require the data engineering stuffs in a particular company and all. Okay, and what are the different things we are doing, how we are preparing the meaningless source data to meaningful target data, which we are storing into data warehouse and which we are preparing for analytics purpose. So some of the topics we have already covered in yesterday's session. Today, this is the continuation of the same thing. Most probably today or by tomorrow, we'll be closing this business intelligence topic. So after that, from the next week onwards, I will be starting Python. Okay, Python on top of data engineering. So as you haven't, do you have the experience in SQL, Sai? I'm just putting a short name over there, so please pardon me. So, do you have any experience on top of SQL or any other data engineering tools? Sai Siva, can you able to hear me? Okay, so please, let me know. Okay, so that we can try to guide you. If you have very less experience, then there should be some materials I'll be sharing with you and all whatever we have covered till yesterday session and all. Okay. Just this is the continuation of yesterday's topic. Yesterday, we have discussed the overall things, how what are the normal architecture for the data to be loaded from the source system to the target data warehouse. And in the target side, when we are loading the data in data warehouse or data mart, when we are loading the data can be loaded either in fact table or in a dimension table. Okay, so we got to know what is fact table, what is dimension table in yesterday's concept. I'm just touching these things once more time because today we'll be creating data modeling. So this is one of the important aspect to learn what is fact, what is dimension. So before creating fact and dimension table, we must need to know what is fact and dimension. That I have already covered in yesterday's session. Just let me repeat once more time. We have lots of data, but the data generally which are quantifiable. That means on top of the data, if I'm just questioning on top of data, how much or how many, just like this, whatever answer I'm receiving, that is the fact or measures. Anything I can tell, fact or measure. On top of that, I can do aggregation function. So I think you have some experience. Tanvi, you already told you have experience on Power BI. So when you are doing the reporting part, we can apply aggregation functions just like summation, average on top of only fact data. Okay, not dimension data. On top of dimension data, I can do count only. I can count the thing. But if we are doing any kind of aggregation, that should be on top of fact or measures. So what is fact and measures? Just like a quick example, revenue of a company, costing for a particular product, number of accounts, all those things that is quantifiable, that is called fact or measures. So if we store this fact or measures in a particular table, that is called fact table. So over here, just like sales tables, billings tables, you can see the red kite color highlighted column, those are called facts. And apart from that, we have some key columns, just like date key, store key, product key. Those are all foreign keys. Okay, so fact table consists of the keys element as well as the fact or measures element. The same thing is there for billing as well. If I just go to the next topic, what is dimension? Those things are dimension, customer, geography, time. Those we are called dimension. And The dimension table, how those can be declared. A dimension table can be created for a particular topic, just like product dimension. We are storing all the product related stuffs. So for different product I'm having, I'm just giving a product number or product key. This is my primary key for this product table. Those should be unique for each of the product. Similarly, I have different stored outlet. So different store outlet, I'm storing this thing. Each of the record of stored table, their store key is the primary key. Okay. So the same thing is present in the fact table. The key element is present in the fact table as a foreign key. And over here, it's a primary key. We are setting up this way to get the proper data modeling. So when I'll be just showing you the data modeling part, then you can see those primary key and foreign key are getting joined to create the OLAP data systems. What is OLTP? What is a OLAP? We've covered it in yesterday session. So anyone just want to go through this, please check the recording. Okay. Moving to the next slide. Okay. Now I'm just going with some of the terminologies for fact table. So suppose you are going to create a fact table. Okay. So how you will, there are few of the terminologies. The first terminology is called, grain. Grain and granularity, those are very important topics on top of fact tables. So grain. So what is grain? Grain is the business definition of the fact table row. So if anyone tell you or architect tell you, so this should be the fact tables data. So they will not, maybe they will not be giving you the entire table demonstration of a table. Rather, they can say this is the grain and you have to create the fact table. Grain means, okay, grain means a single record, how it can be identified. Okay, so you have a, over here you can see it's a billing table. We have sale ID, bill number, date, item code, store ID, quantity, and amount. You can see, so those last two columns are generally facts, and the other things are, those things are foreign keys. Okay. Now, if I want to say that what is the grain of this particular table, what we can say? We can say it's a sales transaction per store, per item, per date in a bill. So this is called a grain. So grain is just like a single sentence representation that can tell a table's data loading part. Okay. So it's briefing the entire table, entire fact table rather I can say. It's called grain. We have another example. So over there, we can see a particular exam result has been stored over here. Year, batches, exam name, student name, subject, marks. Okay. So over there, I can say marks of a student received in a subject in a particular exam, in an exam. Okay. So just like you can see, for the particular student, Aryan Dev. Suppose I am doing one more things. Okay, I'm removing exam name column. Let me copy this thing. Let me copy this thing and give you some example of brain. SCD example. Okay, let me take this one. Okay, the same thing I'm just putting over here. Actually, it's a picture, I think. Let me check. Okay, I'm just copying this thing. Year, batch, semester, okay, name, subject, marks. Here I'm putting the same year for everyone. Batch, suppose it's fine. 9A, 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 9B, 10A. Finals, finals, media, finals, mid-year. Aryan, Aryan, sorry. Okay, subject. Let me put physics the same way. Maths, English. Again, maths. HYSIC. Okay, here. Okay, let me just eliminate these things and put this thing in higher position and let me maximize the. Okay, so suppose this is our fact table. Okay, just let me know if there is any stuck point or anything. This is our fact table and we are telling the grain is this. Marks of a student received in a particular subject for an exam. Okay, suppose I want to remove one column. What column I want to remove? We can remove subject column. Okay, if we remove subject column, suppose I'm removing or hiding this thing. Okay, now you can see this thing are duplicated. If this is the scenario, actually, in the second class, we told we should not mention duplicate in the normalized table. So fact table should be always normalized. So we cannot take duplication over here. So what to do? These things are duplicated actually. These two are not. So those are based on different subject. As the subject is not there, we are thinking that can be a duplicate records having some wrong data. So when I'm removing the subjects, I need to summation these two row in a single row. So summation will be there on top of this thing. So 94 plus 92, it should be 186. So rather keeping a different row, I'll be deleting this thing. Okay. This is the concept. Suppose I'm deleting this thing. Semester I'm not putting over here. So then for a particular year, particular batch, particular student, what should be the marks? Then Aryan's 2 marks for two different same would be again summed up. There should be another aggregation and row number should be less. So what I'm doing, I'm eliminating one column, one particular column. When I'm eliminating these things, our grain will be impacted. The naming convention of the grain will be changing. Marks of a student got in a subject in an exam. So when I'm removing subject, I need to remove subject column, subject keyword from here. Okay. So when I'm removing grain, it is affecting the granularity as well. What is granularity? I'm coming up quickly. Just to let you know once more time, grain is, just like briefing the entire fact tables in a single name. So that as per the transaction level, what is the transaction level? This mark should be received in a particular batch, a particular semester, a particular subject. What is the things? Based on different columns, we need to determine this thing. If we are changing anything, any columns or anything, that should impact our grain as well as granularity. Now, what is granularity? Granularity, it's directly depending on the grain. So when suppose I'm deleting this thing, if I'm deleting, okay, I already delete the subject, okay, or semesters as well. So here it's a duplicated rows. Again, I need to merge it. It's 264. Okay, I'm deleting this thing. Okay, so we started with 5 rows. Now I can see there are 3 rows, but the data is correct. What issue is this? We are missing some detailing part because a particular student is receiving 264 marks. That is fine. For year 2013, his batch is 9A. But what we are missing? The grains or granularity as well. Granularity means how much detailing I can cover up the fact tables thing. So in the beginning, you can see it was segregated, the marks were segregated based on different subject areas. The particular students are receiving in which semester, this marks is been captured in which semester, that is also there. So granularity refers the thing how much granularity level I'm capturing the data. So if we want to make it more granular, number of columns should be increased, just like subject. Okay. So granularity refers to the level of detail of the data stored in a fact table in a data warehouse. High granularity refers to the data that is at near of the transaction level. High granular means we have lots of columns available over there, and based on those columns we can segregate the fact tables data. Okay, so high granular means it's capturing the data at the transaction levels, means at the atomic level. Data that is at the transaction level is usually referred to as atomic level. So whatever we are doing the transaction. So suppose your transaction or in a billing section, we are doing this transaction for a particular unit of product, we are storing it. So if we just capture the same information in the fact, the same transaction level of information, that is called atomic level data. And low granularity refers, low granularity means we are summing up the things. We have deleted some of the columns and we have summed up the particular fact data or fact value. So lower granularity refers to the data summarized or aggregated. What I just done by summing up the marks, deleting one columns and summing up the marks. So here it's impacting both granularity as well as grain. Okay. Is there any understanding issue? Tanveer, Sai Siva for granularity and grain.
No, I understood it.
Okay. Okay, fine. So those are the two main aspects of fact table. Moving to the dimension table. Okay, one more thing I just want to mention. The difference between fact table and dimension table. Uh, so as I mentioned in yesterday's session, we are loading the data into the data warehouse from the source system to the target system. It's not the easy steps. We have staging layer in between us. We have some transformation layer. We have some cleansing layer. Okay. So those kind of different layer we are working, and different functions are being implemented in the ETL tool. What is ETL tool? I'll be coming today. What is the thing and how it's working and all. But just think about it. One thing I just want to mention. Okay, just give me 1 minute time. Give me 1 minute time, please. I'm coming. Okay. So when loading the fact table from the source system to the target, so as fact table is storing the transaction level data, so you can see the data is getting refreshed daily basis. So suppose I'm storing the banking related transaction in a particular fact table. So in a particular bank, for a particular branch, you can see daily basis there are more than thousands transactions are there for a particular branch. So if we check for all the branches of the same bank, so there are more than some millions transaction for a particular bank. So those are all getting stored in the fact table. So what I'm telling this thing because fact table should consist lots of data, lots of record, and the data is getting refreshed. So yesterday, suppose I have 1 millions of records. Today it can be 2 millions of records or more than that. Okay, so those extra 1 million get loaded by today's job or ETL. When the ETL job starts, those are loading the source data to the target fact table. This is the thing, it's going on the ETL tool. Okay, but think about the dimension table. So dimension table, what I just mentioned, it's a product table I just mentioned. So maybe suppose I'm owning a particular factory. Over there, lots of products are being produced. So in a product table means what are the different products I'm storing or I'm producing that is being captured in product dimension table. So over there, you can see maybe whatever data was there in yesterday's date, product related information, it's not present today. I'm just trying to say maybe no new product has been launched. So daily basis, who will be launching product? This is also a factor. This is also a question. So the dimension tables, those are not refreshing daily basis. Just, you can think we have for a particular outlet, we have the product related information in a particular product table. So there we are giving product ID, all the product name, their brands and all. So I do not have a new product to launch for 1 month or 2 months or 3 months. So the product table is unchanged for the entire thing. We have store table. Store is another dimension. The dimension tables actually, it does not change daily basis or the data in the dimension table, those are very slowly changing. The nature of the dimensions are very slowly changing in nature. Okay, suppose we have employee table for a particular company. So maybe today someone joins, some new persons can join, some new persons cannot join. But if anybody joins, the number is just probably less than I have new, new persons joins to my company, maybe total 10 persons for today or total 100 persons for today. So an employee ID is being created there. So for the employee dimension table, some records are getting inserted daily basis, but these records are very minimal compared to fact table. So just I want to say you that for the fact means the transactions levels data, the measures, the main business values are there. Those are very important. The table size are very big in fact table, but in dimension table, the table size is very less because daily basis or hourly basis, the things are not changing comparing to fact. Any doubt till now? Difference between fact table and dimension table, if anyone asks you, So the concept is clear to you, Tanvir, Sai Siva?
Yes, it's
Okay.
yeah.
So while designing the dimension table, we need to think about these three kind of dimension table: SCD type 1, SCD type 2, SCD type 3. For fact table generation, we just need to think about how much granular level we will be capturing the data based on our project requirement or reporting the visualization requirement as well that I mentioned in yesterday's session. As you are a Power BI expert, you should be knowing that if you do not have the transaction level data, if you have the transaction level data, you can do any kind of analysis. But suppose in the Excel side, I just showed to you, I eliminate subject column there. So I am summing up and sending the data to you. Okay. Then you will not be able to determine if the principal of the particular school or college will say you create a charts and graphs for the particular student. The KPI should be such like the students is receiving marks per subject per year per semester. Then you will not be able to get this kind of information from the fact table, as you are not receiving the thing from the fact table because I have eliminated subject columns and I have summed up the marks there. Then you will not able to create the charts and graphs on the particular requirement. You have to tell the principal, sir, I will not be able to create it because we do not have such granular level data in the fact table. Okay, so this is the thing. Actually, we need to think about the KPI. It's a top-down approach. How we'll be creating the KPIs and all. Based on that, we'll we will create the fact tables, the columns of the fact tables, the grain, the granularity. We need to think about that. Now, for dimension, it's also the same thing. What should be the number of columns required? The same thing. Whatever required at the KPI side for any dashboard, I need to introduce those columns into the dimension tables as well. But dimension tables are of three types as of now. I can tell you it's type SCD type 1, SCD type 2, SCD type 3. SCD means slowly changing dimension. So I have quick examples on top of this SCD type. Let me share my Excel sheet once more time. Yeah, I have this example ready. This is very important concept and also you can get questions. What is SCD data, SCD type dimensions and all. So SCD is slowly changing dimensions, different type. Okay. So we are storing this example or data for a particular table. It's called employee table. I'm storing employee related information for a particular table. Okay. So yesterday I have the dimension data or dimension data just like this. This is the example for SCD type 1. This is for type 2. This is for type 3. I'm not going to this thing as of now. I'm just focusing on type 1. So yesterday in the particular employee dimension table, we have this many records. 1, 2, 3, 4 are 4 employee IDs. Those are the employee names. And you can see their designation, different designation. Employee 1 is a trainee, employee 2 is account manager, employee 3 is a developer, employee 4 is senior developer. Okay, so today when the ETL loads were completed, we found two different changes. First changes is employee ID 1 just completed 1 year for today. In today's date, 1 year ago he joined. So that's why I have updated. I mean, not I. So the particular information from the source side, after loading the data, I can see employee ID one's data has been updated from trainee to developer. His designation has been promoted and he has been assigned a developer role. Okay, this is one change as well as I can see one more change. A new record has been inserted means a new person joins the company as well on today's date. Okay, employee ID, I just put the employee ID 5 for that particular person and he is a trainee. He or she is a trainee. Now, so I'm storing two new things. One record is got updated, but it was there, it got updated, and a particular record, this one is inserted newly. Okay, but for SCD type 1, this is one kind of storage system and the simplest one. This way we can store the dimension, but over here we are not maintaining any history. So if anyone wants to check, or if the boss wants to check which particular date the particular employee ID has been, got the transition from trainee to developer, we do not have any answer by checking this employee related table. Or maybe I want to check for the employee ID 3. Okay, so whether he or she directly joined as a developer, switching from a different company, he or she joined as a developer, or he or she joined as a trainee and getting promoted, he or she becomes a developer. Those are very valid questions. Based on that, the promotions are dependent, the ratings are dependent, the particular what the thing, you are working in a company for last 5 years, but someone joins from a new company just few times ago. So few years back. So uh, that is depending on lots of parameters are dependent on top of that. So we cannot able to identify those things if we are storing this. The information by this way. Okay. So for this thing, we need to get with SCD type 2, where we are maintaining some history. How to do that? We are just introducing a new column called date. Okay, over here. So I'm just trying to the same thing. We have this data earlier, 1, 2, 3, 4. Now in today's date, we received a new resource called this. I haven't. Okay. And that should be today's date. Okay. That should be today's date. Suppose 18th August 2021. And you can see employee ID 1 ABC trainee. He was there on that particular date. And okay, the date is wrong thing over here. Let me update it. Let me update this thing. 18th August, and he joined maybe 18th August 2022. Now 2023, he becomes a developer. Okay, so this is the data. So I am storing in a new row for that resource. As the data got updated, I just entered the row with today's date, 18th August. Okay. So by checking this thing, when this particular resource again promoted, a new row should be inserted at the dimension table. For this scenario, we are keeping employee ID as a primary key. Over here, I cannot say employee ID is the only primary key, because when we are storing the data in SCD type 2, we can see employee ID can be duplicated. When the designation has been updated, I have to I have to insert another row to identify this new transition. Okay. So there we have to create a surrogate key, just like employee ID and employee designations. The combination of these two columns can be a primary key. Okay. So this is the example of SCD type 2 information where we are maintaining the history.
So is that like is a foreign key or like is a primary key?
Yeah. Over for this case, I can say the combination of employee ID and employee designation is a primary key only.
Okay, okay.
It's a surrogate key. It's a yes. It's a combination of two keys. But just like employee ID, you can think a particular employee ID. This thing is changed. That's why two different row has been introduced for same employee ID. So the combination of these two can be always the primary key. But only employee ID cannot be the primary key because here the duplication has been occurred. Okay. And no foreign key over here as dimensions. As we know, in generally dimensions we are storing the primary key, and the fact tables we are storing the foreign keys so that we can join between the fact table and dimension table. Those things I am coming when we'll be trying to check what is data modelings and all quickly. Okay, so when we are learning SCD type 3, we are not introducing a new row over here, rather we are introducing one more columns, just like in this way. We are maintaining the particular date when the transition happens, and we are putting one more columns called previous designation. Okay, so this is another way of storing data. It's called SCD type 3. What we are doing, if any new records are coming, so we are updating this thing developer. The transition date is fine as well, but we are updating the previous designation to training. Okay, this is nothing. So here we are introducing a new column called previous designation. So any new records got updated, we can store this thing. But this way we cannot store all the history. Suppose one history back, I'm storing this thing. So one column is sufficient over there. Okay. So if we want to make all the histories loaded, then we have to create some more columns with having some degrees, just like this is the exact parent degree, that's why 1. So previous designation degree 2 I can put. So this way we can implement number of columns to maintain all the history for the employee table. And this is the way we are storing SCD type 3 information. So any one of them we can use during creation of the dimension table. Okay, based on your project requirement, based on the architecture, what kind of data you requires or what kind of data you need to represent in the KPI dashboard, that is determined by the architect, and then the dimension columns as well as the storing methodology, data storing methodology should be determined. That is clear, Tanvir, Sai, any questions for the dimension?
No, it's clear now. I think
Okay,
I
okay.
understand. So it's basically for every new column that we are adding to clarify for every new information. That is why there are different types
Yeah,
are getting started
this
here.
is for SCD type 3. Correct, correct.
Yeah. Okay.
So
Understood.
you can see that SCD type 1 is the simplest one, but we
Yes.
are missing lots of information. Suppose in your
Yes.
KPI dashboard, user want to see what is the previous designation, or the employee directly joins.
Mm-hmm.
Okay, not only this thing, the data scientist, even in my particular project, I was working in a life science project with a particular pharmaceutical company in my previous company. So over
Mm-hmm.
there, uh, they are storing all the things, the transition, there may be SCD type 2 data. Okay, and it's a pharmaceutical products, as I mentioned. Over
Mm-hmm.
there we have patient related data stored over there, particular
Mm-hmm.
patient IDs, name, when they have started medications and all the things. So data scientists, they are creating the probabilities of satisfaction index. Okay, and based on their purchasing thing and all purchasing frequency, they're comparing the things from the previous ones and the now, the recent ones, and they're creating one probability. Okay, so when they're creating probability, we can see just like they are telling it's 94% of the satisfaction index. Maybe, I mean, there are chances of 94% that the particular patient should be leaving the medication from that particular client.
Mhm.
It suddenly happens on the very next day, the particular patient, I mean, left the medication from that company and he or she started medication from another company. Okay. So, this is why the data scientists are required. They can forecast the thing quickly. So, similar thing. The employee think how they're doing the certifications, what are their learnings based on their different strategy. A company can able to understand a bit whether the company, whether the particular employee is going to leave that particular company. Maybe the salary structure, maybe his dissatisfaction index, maybe from another things, his manager is not good, he's not watching, or he's not cooperative. Maybe he's not liking his work at all.
Mhm.
Okay, so based on all those data nowadays, every company wants to, I mean, just be in a safe position. If in a certain days all the employees or most of the employees are resigning from a particular company, then who will handle in the business? Then the company might be ready. Data scientist will be saying the probability. Then the decision maker have to take the decision whether
Mhm.
we need to, I mean, show him more offer. Maybe for the particular patient who is purchasing medications and all. So maybe we are providing some more offers to him or her. Maybe we are personally reaching to the particular person. What is the issue? If there is any issue with the particular company you are facing and all. So different strategy they need to take to. We are now seeing the future. Now we need to take the particular decisions.
Necessary steps.
Correct. So this is the particular things now every organizations are doing. Checking the historical data, they are finding some pattern. Okay, even you in your KPI dashboard, you can also see. So based on a graphs, you can able to identify what can be the next slope for the next quarter. So this kind of thing actually. So they are a bit predicting. There is machine learning as well. They are bit predicting what should be there, and it's not matching 100%, but they're quite matching. So this kind of things, I mean, how much granular level I need to store the data, it's totally based on the architecture, how they will be using that data or utilizing that data. Because if we just storing this kind of more number of columns, more number of rows, the database sizes should be huge and project costing should be also huge. So I need to think about this thing as well, which purpose I'll be storing the data. Okay, and the same thing, I need to check about the costing part, I need to check my project satisfaction part and everything, and they have to determine the number of columns and what should be the column names and all for the dimension and the fact table. Those are not very simple thing. To determine a fact table and dimensions table DDL, it's a very important thing, because on top of that the KPI dashboards are being built. You are quite aware of that thing. So maybe you have started developing a thing, you required a particular columns, but you are not getting it from the data mart side. Okay, so this is the thing, this is the issue. Okay.
Understood.
Okay, so moving to the next slide. Yeah, it took lots of time for that, but this is very important concept. When the concept is clear, then I mean, it's very much clear to you for other things. You are seeing the overall picture, what is being done in the particular things, a particular BI, a particular data engineering thing. Okay, data modeling. So yeah, I mean, today we have just checked the fact table and dimension table. So in the fact table, we can see the foreign keys are present. Then some facts data are also present. Just like over here, time key, product key, store key, customer key, clerk key, register key, promo key, dollars. Okay, till promo key, those are all foreign keys. You can see each of the keys are available as a primary key in the dimension table. Time key is a primary key for time dimension. Store dimension, store key is the primary key. Clark key is from Clark dimension. Promo key is from the promo dimension. Product key is from the product dimension. So you can also check each of the dimension tables data may not be refreshed daily basis because a new store cannot be introduced quickly in a single day. I am a owner of a particular brand. My outlets over there in my country is nearly suppose 20 outlets are there. So today in my tables of store key there are 20 records are present. Okay, but tomorrow it cannot be 21. On a certain day I cannot increasing these things. So I maybe in a year I'm introducing a new store. So maybe in store key in a store table the data changing frequencies maybe once in a year. Okay, so this is how the dimension works, and in the fact it's the transaction level things. We are this kind of dollars sold, units sold, dollars cost, those kind of things are changing per second. So fact related information, a particular transactions is occurring anytime, any moment. Okay, we are loading the data maybe in a single day. Maybe at the non-business hours, we are loading the previous day's records over here. That is fine. But the original data, it's changing per moment. Okay. So that is why fact table is very, very, very important table. And it's very large in size as well. So similar kind of stuff. I just want to mention product key is there, customer key is there, register key is there. So all those things are foreign key. So the entire things are called data modeling. So before handing over the fact table and dimension table to the reporting system, or before using these things for reporting purpose, we need to join the fact table and dimension table, and we need to create an OLAP system so that in a single table we have all the columns. We should be having we should not require time key, then we need the particular date time. We do not require product key then when you are creating a charts and graphs. So you are not creating a graphs, a bar chart between product key versus product sold. There you need to replace product key information with the product related information. What is the brand of the product? What is the name of the product? Because in the charts and graphs, it should be visible not only product key. Product key should be an alphanumeric key or maybe an integer key. Suppose 1, 2, 3, 4, 5, it's a product key. But when I'm presenting the same information in front of user, the user will not understand what the product key is. So that's why we need to create the data modeling first. We need to create the OLAP system, online analytical processing. There all the columns should be present and all the relationship between the columns as well as the fact information should be there in a single table. And on top of this table, we will be creating our charts and graphs or different dashboards. So this is very important topic. It's called data modeling. Okay. I hope it's quite clear because you already worked in Power BI, Tanvi. So
Yes, yes, and like in the relationship table in Power BI, you have to like relate one table with the other. So yeah, kind of understand
correct,
it,
correct,
the concept of it.
correct. Maybe Power BI, we are creating this kind of relationship
Yeah,
by pictorial
relationship
diagram.
type. Yes, you sometimes they are giving you some built-in relationship table, and then
Mhm.
if you want to change it, you can always like create different connection with one table with another, and that will help create those measures and columns sort of thing.
Correct, correct, correct. So over there, one more things I just want to tell. So over there, when we are setting up relationship over here, we need to check the cardinality. Cardinality means when we are setting up relationships, whether they are one-to-one relationship, maybe one to many, maybe many to one. So just like when I'm just checking for these two information, we are joining these two table based on product key. Okay, so when we are joining these two, we need to check the cardinality, whether the relationship between fact table and product table is 1 to 1 or many to one or one to many. This kind of relationship is also matters that particular fact tables and dimensional tables relationship. Otherwise, the data should be wrong in nature. It should be duplicated and the data will not be properly reflected as well. Okay. So, what are the different kind of data modeling now I'll be referring over here? Okay. So over there, what kind of different data modelings are there? So if we just going to have these questions, so there are two data modeling schemas are available. That is called star schema and snowflake schema. I hope you are aware of this thing, but let me uh, just repeat this thing. What is star schema? Let me go to directly pictorial diagram. Okay, I can. Okay, you can see now over here. Okay, this is the representation of star schema. So for star schema, we have a single fact table and we have different dimensions tables in this manner. Okay, so this is called fact table. Those are dimension table. Just like in the previous examples, we just have the examples on star schemas only, and those are very simple to build. Okay, and what are snowflake schema? It's called snowflake. So over there, this is a quick examples over here. This is the main fact table. Those are different dimensions. That is fine. Till that is fine. Product is fine. But you can see there are two different dimension tables who are not directly, those are not having the relationship between fact tables and dimension tables. Okay. So over there, we are segregated this product table. We are setting up this brand table. This brand table is having the relationship between product table. So the particular fact table is getting related to this brand, not in direct manner. In this manner, they are getting related. Again, if we are just trying to reach category, we have to go through this way. We do not have direct relationship between fact and dimensions. So in Snowflake schema, we do not have direct relationship between fact and dimension. Rather, we have the relationship in this manner. We have direct relationships between fact and this one or two dimensions. Rather, we are setting relationships between these two dimensions and the data is getting fetched. It's a bit complex and in original or ideal scenario should be always star schema, but it's not possible always to create a relationship between fact tables and dimension tables. So in the original or the online go live product or business product, we can see this kind of snowflake schema much more available than that of star schema, because in star schema's example we found all the tables are directly getting having relationship between fact and dimension, but this is not the scenario all the time. We have lots of tables required, maybe 20-30 tables are required. Not all the time we are not able to introduce the particular relationship between fact and dimension. So that is why these concepts are coming, just like creation of snowflake schema. Okay, it is understandable.
Yes.
Okay, okay, okay. Do we have time for ETL, or let me cover the ETL topic for tomorrow? So
Okay.
tomorrow we'll be closing this topic. ETL means the same thing we are telling in yesterday session. The main job which are loading the source data to the target till fact table and dimension table, and after that, when the fact table and dimension tables are refreshed, then we are handing it over to reporting side or visualization side to refresh the dashboard, so that the dashboard should be having updated record. So when we are just going with ETL means extract, transform, load. I'll be just in detail, will be starting this topic from tomorrow. So how the data is getting loaded from source to target, what are the different strategy or refresh mode of extracting the data from the source system as well as loading data at the target system. So this all those things we'll be learning in tomorrow's session. Okay. So,
Okay.
but if there is any stuck point, any doubt, please ask me. Okay.
It's okay. All right. To
Okay. Then that's all for today's session. Let's connect
Okay.
tomorrow.
Sure. Bye.
Yeah. Thanks. Bye. Then.
Thank you.